Hey everyone, it's Garrett again, and I'm back with another open source project that I'm super excited to show you all. So, this is called Project Saturday. It's a toolbox for the vocal computing age, which means it contains components that allow you to build elegant voice interfaces to modern large language models. You can think of it like the tools required to build your own J.A.R.V.I.S. So it's powered by WebRTC, which means it has a very portable interface allowing you to deploy it anywhere, whether it's a phone, Android, iOS, Linux, Windows, Mac OS, or even like a Raspberry Pi. I'm going to be showing you how to get started and run the demo. I have a demo included, which allows you to run a local version of a J.A.R.V.I.S-like assistant. One thing to call out is that I've only tested this on Mac OS with an M1 Pro or Max processor, so your mileage may vary on other operating systems. If you run into any issues, please open an issue, and I'll do my best to help you. So we're going to start with a fresh git clone, and once this is done here, I'm going to cd into the repository. So first things first, we want to cd into the text-to-speech directory. This contains the code that will actually run the text-to-speech inference. I'll explain what that means in a second. So first things we want to do is Python 3. We want to create a virtual environment. Feel free to not do this if you don't want to. I will choose to do that. I'm going to activate it. And then we're going to pip install -r requirements.txt. And so that's going to download now. Basically what we have going on here is there's three main tool types. There's speech-to-text, text-to-text, and text-to-speech tools. Speech-to-text is going to take your speech, turn it into text, pass it to the text-to-text tool, which is going to, in this case, is ChatGPT, which is going to generate a response to your prompt. And then from there, we're going to take that output, turn it back into speech, pass it back into the WebRTC call on our computer. Like I said, a WebRTC server is the backbone for this. It is running locally. It's not going to cost you any money to run or anything like that. The packets never leave your computer. All the data is flowing internally. The reason I chose WebRTC is, again, for the portability, and this will allow you to split this out and build it as a distributed system in the future. So what we can do next is we can go ahead and run the RTC server. This doesn't have any dependencies it has to download, so that should just pop up right away. And then we can also run make client, which is going to start setting up the client. This kind of pieces everything together. It connects to the WebRTC call, starts listening to your audio, determines when it needs to run the inference, and then takes the audio that it turned into text, passes it to the text-to-text tool, which then generates output, passes it to the text-to-speech tool, which then generates output back into the RTC call. That will be output as text that you can hear. I apologize for the noise outside. It is very noisy on the street corner. I will say one thing you will need for this is an OpenAI token. That is because I haven't had time to get the local text-to-text inference working yet. I want to do something with Llama CPP. However, I've been on holiday in Scotland and other bits of the UK and haven't had great Wi-Fi, so haven't been able to download the models yet. But when I get back, I plan to work on that as one of my next big roadmap items. So let's see, right now we're downloading the Whisper CPP model. And basically what we did is we built a lib that we could link against and then downloaded the model that we needed, and now we're running the client. So we're going to come back up to the top here, and we're going to make TTS. This is going to run the TTS server because it's behind an HTTP interface that allows for easier inter-process communication between the Go client and the Python server. One of the things I'd like to do in the future is also try to build a C-based text-to-speech inference engine. I don't know if anything like that exists right now. This one is written in Python, and honestly, I don't really like working in Python. So it can be a bit of a pain. Okay, great. Everything is up and running. So we have the RTC, we have the client, we have the text-to-speech server. one thing to note, you need to start the RTC server before you start the client, and ideally you have the text-to-speech server running before you have the client running as well. I need to write some better code, but I want to get this released for everybody and start building a community and seeing if we can get some more people to work on this. So we can pop over here. This is the web page. I'm going to refresh, which means I need to, crap, I killed the wrong one. Start this again. Every time you refresh the page, you need to rerun the client too. Like I said, need to write some better code, but we'll get there. Okay, so note your microphone will be muted when you join this. I gave a live demo of this at a conference talk 2 weeks ago and wanted to add that so something didn't go wrong. But right, so we click this button and then we can talk to it. Hello, what is your name?
Hello, my name is Saturday. How can I assist you today?
Can you tell me a joke?
Of course. Here's a classic one for you. Why don't scientists trust atoms? Because they make up everything.
Great. Can you write me a poem about the weekend?
In a world where weekdays rule with might, a glimmer of hope appears in sight. As the sun sets on the corporate grind, the weekend arrives, oh how it's kind. A respite from the bustling routine, a time for tranquility to convene. Saturday dawns with promising glee, embracing leisure and setting us free. Sunday follows.
Okay, you get the point. But yeah, so this is the demo. Basically, the way to conceptualize this is the repository contains all the tools you need to build this type of software. I really think vocal interfaces are going to be the key to the future of computing for us. I think the best interface with a computer is one that you don't have to look at, you don't have to think about, you can just speak to. As we continue to be more involved in these digital lives, I think we are going to kind of see a swing away from the hard physical interfaces towards interfaces that are a little bit more seamless. And I think modern large language models hold the potential or hold the key to enabling this type of interaction with computers that we've been missing for so long. Where am I going to take this in the short term? Right now, I'm really focused on shoring up the interface and making it easier to deploy. Obviously, we had to jump through some hoops to make it work, but I'd like to get that as simple as possible. I'd also like to get local inference running with something like Llama CPP. That way we can get off of OpenAI. Outside of that, there's a couple projects that I want to build with this software. So I'm just going to be building and using the interfaces outlined here. I invite you to do the same, start building stuff with this, and that way it's going to kind of influence where this project needs to go and kind of solidify the interfaces and the abstraction level that we need to reach for there. If you have any questions, feel free to reach out to me and let's chat. Like I said, I'm looking to build a community of people that are really excited about speaking to computers and want to kind of work towards that future together. I think by open sourcing this technology, we can greatly expedite that future. And so that's my goal with this. Join our Discord, stay up to date with the community as things evolve and as new features happen. We'll probably be hanging out there and chatting a lot more. But until then, thanks for taking a look.